Interesting. My name is Ropelewski. I'm the director of the Biomedical Applications Group at the Pittsburgh Supercomputing Center, and I'm going to talk to you this afternoon about Galaxy on Bridges, which is our latest supercomputer that has been funded through the National Science Foundation. Bridges is a really unique supercomputer. It's not like in the old days when we used to have crays and these massively parallel systems. Bridges itself is designed to be a system really for workflows and for data-intensive problems. It supports popular languages that people are using today. It's not necessarily a C and Fortran machine like supercomputers of old. Support everything from R, MATLAB, Python, etc. A unique thing about the resource itself is it's the first deployment of the Intel OmniPath architecture. And with the Phase 1 hardware, it's listed up here. There's going to be a Phase 2 where we get some additional nodes as well. But one of the things that you can see from the specifications is that it's a machine that has both nodes that have a small amount of memory and nodes that have an enormous amount of memory. And this is very useful, particularly in bioinformatics, because when we look at workflows in bioinformatics and in other fields as well, we find that some of the applications that we need to run are essentially serial operations. So we really can't get much parallelism out them. Other applications require an enormous amount of memory, and still others require a lot of cores, but not a whole lot of memory. And if you think about doing this on a traditional machine, traditional machines really aren't set up to scale across memory. And that's one of the unique things about Bridges and why we think Bridges is the ideal machine to run Galaxy. Now, we plan to support a number of different Galaxy scenarios on Bridges, and I'm going to go through a few of them with you this afternoon. The first is that we do intend to, and we do have our own Galaxy instance set up on Bridges. And this Galaxy instance, there's not much difference from it from a lot of the other standard Galaxy instances that you see around. One of the big differences is, though, that the way it's set up is that if you have an XSEDE project, you can authenticate to the server using your XSEDE credentials. And so you can get, if you have a really large project that you have to go through the XSEDE allocation process to get time for, it really is a nice system because you can authenticate directly to your to the server using your XSEDE credentials. We also, through virtualization, will maintain Galaxy instances that we call our user-supported Galaxy instances. So this isn't the main Galaxy instance that everyone who's an XSEDE user has access to, but it's rather a Galaxy instance that perhaps you might want to use for a class, perhaps for a workshop, or perhaps you want to just host a Galaxy instance somewhere and you don't have the computational resources to do it. Maybe it's in a different field. Maybe it's a cell modeling field, for example. So we intend to maintain the Galaxy instances in this way as well. The third scenario that we're working on is to use Bridges as a back-end compute server for other Galaxy instances that are out there. Mainly this is using the Pulsar technology that's been developed, as well as we intend to, in addition to supporting the Pulsar system, we also want to make the system work with a special file system that we developed at the Pittsburgh Supercomputing Center that's available for people to install locally, and that's the /2 file system. And an advantage of the /2 file system is that it handles the data transfer for you automatically behind the scenes, so you don't have to physically move the data from one place to the next. And with that, I would like to thank you for listening to me. If you would like some more information, I have a few URLs listed up here, both how you can get time on XSEDE resources, particularly how to get time on the Bridges resource, as well as the Bridges development plan. If you're a hardware junkie and you want to find out the exact number of processors and cores and who the vendors are for each component, it's listed on that URL as well. Thank you.
Did you use Pulsar with Galaxy to submit to the cluster?
I'm sorry, I
did you use Pulsar?
We've tested Pulsar, yes.
And how is it, in terms of file transfer?
File transfer?
Between the Galaxy and the cluster and the other way.
Ultimately, the file transfer really depends on how good of a network connection you have between the sites. So testing it between TAC and the PSC, the connection's very good. So we get fairly good.
I'm not talking about the connection, but I mean the file transmission protocol. Did you use something else other than HTTPS, for example? Did you use some grid FTP or something like that?
I'm not sure how things are configured. I wasn't the person who tested it and has those details, but I can get them for you if you leave me your name and I'll send them to you.
And it will be nice if this presentation will be shared, the file on the website.
Thank you.